Hello everyone and welcome back to this live stream for GCSE AQA Chemistry Paper 1 revision session. Now today we'll be covering all of the topics that will possibly come up, and the ones that even might not come up, we'll cover them, as you never know with the GCSEs which topics will come up, won't come up, and predictions are used to know what to revise, but you should prepare for everything, whether you think it will come up or you might not think it'll come up. So in 1 or 2 minutes we'll be starting today's live stream. So we'll start off with atoms, elements and compounds. So an atom is a basic circle which is made up of a nucleus, a central nucleus. The nucleus comprises of protons and neutrons. And it is made up of neutrons and protons like this, both mixed, and is surrounded by shells of electrons, such as this. So what we need to know is that the atomic number, the AR, equals the number of protons. This is the same for any atom of the same element. So for a gold atom and another isotope of gold, as long as it is gold, the number of protons remains the same. However, for isotopes, the mass number is different. The mass number is the protons and neutrons, both together. And this can differ in isotopes. So sometimes in isotopes you may have the same number of you can have, so an isotope of carbon could be 13 and 6 carbon and 12 and 6 carbon. As we can see here, the atomic number is 6 and carbon has 6 protons, and as the mass number here, 13, is the number of protons and neutrons, 13 subtract 6, that means we have 7 neutrons in this isotope of carbon. 7 neutrons. However, in the isotope beneath it, we have 6 neutrons. Therefore, they are both carbon atoms. They both have the same number of protons. However, as the number of neutrons are different, they are both isotopes, so the mass number is different. Now, elements are substances made of one type of atom. So gold is made up of many millions of different gold atoms which are chemically combined together. which are together. Now, compounds are two or more elements which are chemically combined or bonded, such as salt. Salt is NaCl, sodium chloride. So in sodium chloride, you will have sodium atoms and you'll have chlorine atoms, which will be bonded together with a chemical bond. So unlike a mixture, you may have done a practical in year 9 or year 10, a teacher practical for the mixture sulfur and iron, where you'll have iron filings in a mixture of sulfur, and with a magnet you can pull them out. So in that practical, you will know that it can be separated as it is not chemically combined, and the sulfur and sulfur and iron are just mixed together, so they're not chemically combined. However, you can't separate sodium chloride, the sodium or the chloride out, as there's a chemical bond and they're chemically combined. Moving on to mixture and separation techniques. Now, mixtures can be separated by physical methods: filtration, distillation, crystallization, and chromatography. Now, filtration is, if you'd have a beaker, you'd have a cone of filter paper, and if you were to separate insoluble substance from a solute, so let's say you'd have small iron filings in a solution such as water, you'd pass the water through here, the water would collect in the bottom, and your iron filings would collect above here, as it is too big to fit through the filter. However, the water can pass straight through. Then we have distillation. Now, distillation uses different the boiling points of different compounds to separate it, such as in paper 2 for fractional distillation is a similar process. So you'll heat the sample in a round bottom flask. Then, as if you have two chemicals together, let's say you have two solutions, the one with the lower boiling point will boil at a lower temperature and it will condense up towards the top. Now, over here you will have a condenser. Now, what the condenser does is, in the name, it condenses the vapor, what has condensed upwards. So it'll pass through here, and on the condenser there will be a tube around the outside where there'll be cold water. Now, the cold water brings down the temperature of the condensed vapor and will turn it into a liquid, and it will allow the vapor to be turned into a liquid, and it will collect in a secondary flask on the side here. So the liquid or the solute with the lower boiling point will condense up here, will vaporize up here, evaporate there, condense down here, and collect over here, and you'll be left with two separate solutions. Now, this only works effectively if there are differences in the boiling point. If the boiling points are similar, then this may not be as effective. Now, crystallization, you may have done the practical with the copper crystals, calcium crystals. What you will have in there is that you will heat it up gently in a small container like this, and you will allow crystals to form by cooling it, warming it, cooling it, and warming it, and that will cause the water to evaporate, or the solution to evaporate, and that will allow the crystals to form. Next, we have chromatography. Now, chromatography you may have used in biology as well. It separates two solutions based on their affinity. Now, the affinity is how much affection sort of it has for the paper, how attracted it is to the paper. Now, in chromatography, you will have a beaker here with the solution, and you will have chromatography paper. Now, the chromatography paper, is important to note that the chromatography paper should be suspended. It should not be touching the sides here, or it should not be touching the bottom. Now, it should be suspended so that the bottom just about dips into the solution, into the solvent here. Now, the solvent could be anything such as water. Now, on the paper, you will get your solution or your thing you're trying to find out. So, let's say you have a pen ink. You might put a dot of pen ink here on this line here, a bit above the line, here, one dot here, and one dot here. And something important to note, this question could come up, and it is very likely that it'll come up, and it usually comes as 2 or 3 marks. He will ask you, what should the line over here be drawn in? Now the line over here, you should draw a pencil line here. The pencil line here allows you to see where the dot had started. Now if you use a line here with pen, then as we know that the water from the solvent will move up here, and it will carry the ink up the page. However, if you have pen ink, the pen ink will also be carried up the page. Someone in the comments is asking, can you explain this point again? Can you elaborate which point I should explain again? Sorry, I did not read your comment. And the question about chromatography, it could be 2 or 3 marks, and it has come up in the past. It will show you a setup that a student has done, and it will tell you that they have that the paper is touching, or that the line is drawn in pen, and they'll ask you what is wrong with it, what could go wrong, and how you can correct it. This point again that we have done right now. So in chromatography, you know that you have a chromatography paper, such as drawn here. Now on there, if you want to test how pure a substance is, such as the ink of a felt tip, let's say, you will get the ink of a felt tip, and you will draw, let's say, the red ink. You will put a spot over there, a tiny spot. Let's say you want to test the orange, you'll put another spot there. And let's say you want to test the blue, you'll put another spot there. Now, what you need to do next is that you'll get a beaker of liquid, and the liquid will be full of a solvent. Now the solvent will be absorbed by the chromatography paper, and it will carry the ink up the page depending on its affinity. Now the affinity is how attracted the solution is to the paper. Now, let's say the red ink is made up of 1 dot. The red ink will sail further up the page, up here. Now, the orange, let's say the orange, as we know, it's not a primary colour. The orange, let's say, is made up of red and yellow. So the red will separate up there, and let's say we'll have yellow. The yellow will separate down here. This is just an example. Now, let's say the blue has a higher affinity. As it has a higher affinity, it's more attracted, and it will be carried up higher to the page like this. And like this, we can find out the affinity of different substances. And the reason we have the solvent here is that the solvent carries the substance that we are testing up the chromatography page, chromatography paper. Now, an important point to note is that for the RF value we are going to calculate, you need to draw a line so that we can measure how far up the solvent has travelled and how far up the ink has travelled. So the line that we should draw is the starting point of where the dots are. So we should just draw a dotted or a faint line in pencil. Now the reason I say pencil is that if you draw the line in ink, then the solvent will carry the ink up the page, and that will cause an error in your working. And that is a common exam question, and you will say, why has a student made a mistake when they have used ink to draw the chromatography line? Now, the chromatography line, if you draw in ink, as I just explained, it will move up with the solvent, so it will be incorrect. Someone asking in the comment section, any paper predictions yet? Now, we only have 1 day till the chemistry exam. In many cases so far this year, there will be many incorrect predictions. That's why I don't do them. However, you should be doing past papers, and especially the questions that don't come up. It could be very likely that they could be tested, or any questions that keep coming up, such as this question we are doing right now. You should learn common misconceptions and learn the topics, and you should just learn any misconceptions that you have and cover all the content before tomorrow's exam. And practice makes perfect. You should be doing past papers, maybe not too intense, but just the long format questions that carry a lot of marks. Now, the RF value is the distance moved by the substance divided by distance moved by solvent. So the solvent, when it moves up the page, we'll be able to see that it will have a solvent front, which will be a line, let's say till here, and you'll be able to see as the color of the page will be different, as you can see that it has been as it has absorbed the solvent up the page. And then let's say the solvent has moved up, let's say 85 millimeters, and the substance, let's say the ink, has moved up 68 millimeters. So the RF value will be 68 divided by 85, and 68 divided by 85 is 4/5, which is 0.8. So that would be our RF value. And that just tells us how much affinity the substance has for the page. And chromatography could be used to find out different chemicals and is a separation technique. Moving on to the history of the atom and the periodic table. Now, the models evolved from John Dalton's inseparable circle. So he believed that atoms were inseparable circles. They're solid balls that could not be divided. And then next we had Thomson's plum pudding model. So the plum pudding model was that it was a positive, an atom was a positive ball with negative electrons scattered around it, such as a pudding which would have plums in it, hence where the name comes from. Next we have Rutherford's nuclear model. So the nuclear model was something like this, and it was based around a positive nucleus, just like today. However, it had electrons floating around in orbitals, such as this shape that you may have seen quite a lot. Someone in the comment is saying that they're really scared for tomorrow's exam. Just make sure that these exams do not define you. You just need to try your hardest. Make sure you have covered all the contents, and any content you are unsure on, just watch a free science lessons video. They're really good for understanding the key concept. And if you start from the start of chem, you'll see that many topics build upon to each other, and that will really help you. Next we have Bohr's electron shells. Now that is something similar to what we have today. There are electron shells orbiting around a positive nucleus. Atomic mass is by mass number. So let's say you have carbon. Find carbon 13, an isotopic number, very soft. They have low melting points and reactivity points, and reactivity, because let's say the first element has 1, the second element may have 2. So the outer electron gets further and further away from the positive nucleus. Attraction is going to be much less than if group 1 metals lose an electron halogen down the group and they displace less reactive halogen. Bromine, for example, and you have astatine, sodium bromide, and you have sodium astatine. If metals are non-sodium, and you have chloride. Na, sodium, will lose an electron to form, and that will form Na. Ionic compounds have giant lattices, such as NaCl. NaCl is formed by alternating sodium and alternating chloride, such as this would be sodium, this would be positive, and a sodium, and a negative pairs of electrons between non-metals, and these are strong bonds. So let's say you have nitrogen. Nitrogen has 5 electrons in its outer shell, like this. And we have another nitrogen. Now the other nitrogen also has 5 in its outer shell. So now, as we know, nitrogen is diatomic. It exists as N2. Now the reason it does this is it is covalently bonded. Now nitrogen, it has 5 electrons in its outer shell. However, from those 5, 3 are shared in the middle from one nitrogen, and 3 are shared from the other one, like this, as such. 6 electrons in its outer shell. So the oxygen, it will have 1, 2, 3, 4, 5, 6, and the other oxygen will have 1, 2, 3, 4, 5, 1, 2, 5, 6. So now both of the oxygen atoms have 8 electrons in each shell due to the sharing of electrons. However, they initially have 6. So this is how a covalent bond is formed. Now, covalent bonds are strong bonds, and they form between two non-metals. So between metals is a metallic bond. Between metals and non-metals it is ionic. However, between non-metals it is covalent. Now, covalent bonding is between simple molecules, and simple molecules which are covalently bonded have low melting and boiling points and do not conduct electricity. Electricity is transferred throughout a molecule by delocalized electrons. Now, delocalized electrons are just floating around throughout the structure, which are able to carry charge, and the ions can do that as well as delocalized electrons. Therefore, there's nothing as such in covalently bonded molecules, so they do not conduct electricity. Next, we have giant covalent structures. Now, diamond and graphite both are made out of allotropes of carbon. This means that they are made out of carbon and they have very different properties. Now, diamond, as it is made of carbon, it can make 4 bonds each as such. Now, the central carbon, this one here, has 4 bonds. Now, this repeats throughout the whole structure, and each carbon makes 3 bonds. Now, this is a giant covalent structure. Giant covalent structure, diamond. Now, as this has many strong bonds, it is very hard to break, and it has very, very high melting points. As there are no delocalized electrons, again, it does not conduct electricity, and it is very hard. Now, graphite, unlike diamond, is soft and it conducts electricity. This is because it is arranged in a hexagon shape. So it has hexagonal sheets such as this, and there are many sheets on top of each other, just like that. And as they are in layers, they are able to slide over each other, and that's why graphite is slippery, and it is used as a lubricant as well. And it can conduct electricity, as delocalized electrons can move between the layers of the carbon sheets. Now, graphene is just one of these sheets of graphite, and as is 1 atom thick, it is very thin, and it conducts electricity well. Next, we have states of matter and nanoscience. Nanoscience is very simple. You have a few structures you need to know, like C60, which is Buckminster fullerene. Buckminster fullerene is made of carbon atoms, 60 of them, in a spherical shape, and it is used for things such as drug delivery, medicine. It is used in sun creams. It is used in lubricants. A question that could come up this year: the reason it is used in lubricants is that it has a spherical shape, so it can easily roll, and it can make things slippery, and it can be used in drug delivery, as it is enclosed in a capsule shape, and it can release it. Someone's writing in the comments, what am I streaming for if you are not going to get it? Could you elaborate what you mean by that, and what you need help on? I'll explain the topic in detail. Next, we have conservation of mass. Now, this is qualitative chemistry. Now, this part of chemistry is very important, as it is just basic maths. However, it is a bit more advanced. It's not very hard. However, once you get the hang of it, it is very easy. And many people are just scared after looking at some of the numbers. Many things that come up are such as grams per decimeter cubed. Something that you should know about the maths in chemistry is that usually what you'd write as grams per decimeter would be like this, a decimeter cubed. Maybe you'd write it like this. However, if you write it like this, the -3 from your index laws, you should know that it means that the grams are over the decimeters cubed. It is not too tricky. It's just a bit hard to understand. Now, in a closed system, mass is conserved. So if a reaction takes place under a closed system, the moles at the start of the reaction, at the end of the reaction, are going to be identical. And the total mass of reactants equals total mass of products. Now, the only time this does not occur is if it is not a closed system, and these changes in mass could be due to gases entering or leaving the system, such as if you have a gas that forms and it leaves, the mass of the gas syringe will be less. Next, we have relative formula mass. This includes stuff like simple stuff such as H2O. Now, you could be given anything such as AuNO3 or silver nitrate, AgNO3. Now, it is not hard. All you need to do is get the MR of each. The MR equals the atomic mass of 2 hydrogens and an oxygen. Now, this is 2 times 1 plus 16, and this is 18. That is the formula mass of water, which is 18. Now, you can use the MR to calculate the elements in a compound very similarly. So if you have, if it says that the empirical formula for compound is H2O, and the percentage mass of the percentage mass of hydrogen is 9%, 11%, is 1/9, and then we know that is H2O. Next, we have moles and calculations. Now, 1 mole equals Avogadro's number. So in 1 mole of let's say gold, you'll have 6.02 times by 10 to the 23 atoms of gold in 1 mole of gold. 1 mole of gold equals its mass number. So let's say in 1 mole of hydrogen atoms, you will have 1 gram of hydrogen. So 1 gram of hydrogen contains 6.02 times by 23 atoms of hydrogen. Now, a formula that you need to know is moles equals mass over MR. Now, this could be used to find out how many moles of an atom you have. So let's say the moles of you want to find out how many moles of water there are in 90 grams of water. Now, we know that the mass of water is 90 and the MR equals 18, which comes from 1 oxygen 16 and 2 hydrogens 18. So what we would do is 90 divided by 18, and that gives us 5 moles of water in 90 grams of water. Next, we have limiting reactants. The limiting reactant is the reactant which is used up first, and it limits the amount of product made. So if you have, let's say, in a real life example, you need 250 grams of 250 centimeters cubed of Vimto, and you have a liter of water, and that makes 1.25 liters of squash. However, if you only have 500 milliliters of water, you make less Vimto as a result, as the amount of water you have is limited. So that is the limiting reactor. Similarly, the limiting reactor is the one which is used up first and you have less of. So the way you work this out is by working out the number of moles of each reactor, and then you work out which one is less than you need from the stoichiometric relationship. So if you have a reaction which says Na plus 2H2O equals whatever it equals, then if you have 2 moles of sodium and 3 of H2O from the stoichiometric relationship, you can see that if you have 2 moles of Na, we would need 4 of H2O. However, we only have 3. Therefore, as this is less, that means that water is our limiting reactor. Next, we have concentrations and solutions. Now, concentrations and solutions also comes up quite a bit, and this formula can get you every single mark in any concentrations question that comes up, or any titrations question. Now, the formula is N equals CV. Easy to remember, CV, what you need for job applications. Now, number of moles equals the concentration times by the volume. Now, if you have anything Next, you're moving on to acids, bases, and pH. Now, you can measure the pH of anything using a pH probe or universal indicator. Now, universal indicator paper, you'd get the paper and put it into a solution, and it would tell you the pH. So, if you put in universal indicator into, let's say, hydrochloric acid, it will go sort of a reddish yellow color. Now, the reddish yellow color suggests to you that it is an acid. Now, the pH scale is something like this. It starts from red to green and ends at blue/purple. Now, this is pH 1 and this is pH 14. Now, neutral is pH 7. Anything between 1 and 7 is acidic. Anything between 7 and 14 is alkaline or a base. Now, what you must know is that 14 is very alkaline and 1 is very acidic. So a very strong acid would have the pH 1, and a very alkaline solution would be pH 14. Now, water is neutral, therefore it would come up as green and is pH 7. Now, something that you must know is that acids Now, what we have next is reactions of acids. Now, the reactions of acids are just very simple. You just need to learn them. An acid and a metal react to form a salt and a hydrogen, such as hydrochloric acid and a metal such as HCl plus a metal, let's say a metal sodium, would give us a salt, sodium chloride, plus sodium chloride plus hydrogen, as hydrogen has been released from this compound here. As we know from before, it releases H plus. Now, an acid plus a base equals salt plus water. This is a neutralization reaction. Now, neutralization neutralizes an acid into an acid or a base, and it makes them both neutral. So, if something's very acidic or something's very alkaline, it neutralizes them. Now, next we have an acid and a carbonate equals salt plus water plus CO2. Next we have soluble salt practical. Now, in this we react an acid with an excess base, and we filter off the excess solid and then crystallize the salt from the solution. Next we have the reactivity of metals. Now, the reactivity of metals. No, Phantom acid is not part of this curriculum, not of AQA. I don't know which curriculum that's part of. So the reactivity series starts from potassium to gold, and displacement reactions occur when a more reactive metal replaces a less reactive one. So if a metal is more reactive, it displaces a less reactive one. So if you have sodium chloride and you have, let's say, sodium nitrate, the sodium is less reactive. So the sodium is more reactive than the silver, so it will displace it, and it will make sodium nitrate, and it will displace it, and it displace the silver, and the silver will be left on the side. I don't know which curriculum Mewing oxide is from. What's Mewing oxide? Is it an element? I'm not quite sure about that one. It's the first time I'm hearing of something. Next we have electrolysis. Now, electrolysis means splitting lysis by electricity. So electrolysis splits compounds using electricity, and it requires ions to move either molten or in solution. Now, to answer your question, it would be an ionic bond if it is between a non-metal and a metal. So as you know, oxygen from the oxide is a non-metal. So if any compound, it doesn't matter which one, if it's a metal, then it would be ionic. However, if they are both non-metal, it would be covalent. I hope that answers your question. So at the cathode, positive ions gain electrons. Gaining electrons is reduction, as we know from oil rig. Oxidation is anode. The negative ions lose electrons and they are oxidized and they are made into normal atoms. So at the cathode there's reduction, and at the anode there's oxidation. Anode, oxidation, they are both vowels, and cathode and reduction, they are both consonants. One way you can remember this. Next we have exo and endothermic reactions. Next we have exo and endothermic reactions. Now, exothermic reactions release energy to the surroundings from, let's say, combustion or neutralization, and the temperature increases. Something you can remember is hand warmers. Now, hand warmers have an exothermic reaction which occur inside it, and that allows energy to be released. Now, endothermic absorbs energy and takes in the energy, and the temperature hence decreases, such as photosynthesis or thermal decomposition. So for the reaction profiles, what it would look like is the exothermic one would look like. So to draw a reaction profile, you need to draw a graph like this. This would be the reaction, so as the reaction goes on, and this would be the energy. So the higher on the axis, the greater the energy. Now, on an exothermic, we'll do first. Let's say the energy starts off from here for the reactants. This is the reactants. Now, the energy will increase until it reaches the activation energy. And it will reach down here, the products. And the energy will go down there. Now this here, the change is the amount of energy released. Now as the energy is released, the temperature has decreased. The temperature of the elements have decreased. The temperature has decreased, and the temperature of the surroundings has increased. Now, for the exothermic reactions is the complete opposite. They start off lower, and the particles in the system gain energy, and energy is absorbed, and in the surroundings the energy has decreased. Next we move on to bond energies. Now bond energies come up every year. They will give you a question. They will give you a question with a reaction, and you will have to work out the amount of energy a bond holds using the change of energy in the reaction. So the overall change equals the energy from the bonds broken subtract the energies from the bond formed. So making bonds, you can remember this using Mexican bend. Now Mexican bend is another mnemonic. Mexican making is exothermic, and bend, breaking bonds broken, is endothermic. And the overall energy change is the energy from the bonds broken, which is released, which is created which is given into the system, given out from the system, subtract the bonds formed, which is taken back into the system, absorbed by the chemical for the reaction. So let's say you have H2O. It would be something like this. The H2O, there'd be two bonds between, there'd be two HO bonds in this, and let's say you want to form, O and HOH minus. So one of the OH bonds would be broken, and there would be only one OH bond left. So this would be an endothermic. This would be an endothermic reaction as they are as an exothermic reaction, as when the bond is broken, energy is released to the surroundings, and it would be exothermic if more energy was used to make the bonds. So the overall energy change equals bonds broken subtract bonds formed. Now if your answer equals positive, then you have an endothermic reaction. And if your answer is negative, you have an exothermic reaction. As in an exothermic reaction, the energy change, as we know from here, the energy has decreased, so the energy change is negative. So the energy has been given out from the system, and the temperature of the surroundings increase. However, if it is positive, it is endothermic, as the energy of the system has increased and the energy change is positive. Next, we are moving on to the practical skills. Now, the practicals carry 15% of the marks in the AQA exams, and usually it will just be these points here, just adapted to a certain practical. So let's say you have the practical. Let's say you have any practical. Now the reproducibility is, can anyone reproduce the practical with different apparatus but the same method? Now the repeatability is in the name. Can anyone repeat it with the same method and the same apparatus? It is very important that you learn the two definitions for both of these differently, as it could very well come up. With the same apparatus and the same method, both of them. I know I've put a slash, but I mean and same apparatus and same method. Now the accuracy is how close it is to the actual answer. How close the result is to the actual answer. So in a titration, you want your titer to be as close as it is to the actual value. However, precision is how close are the results. How close together they are. So if you had a bullseye, and a way to remember this is accuracy, this would be not an accurate shot. However, this would be very accurate. However, precision is how close together they are. So if you had one shot there, and one there, that would not be very precise. However, if you had 3 shots, all very close to each other, that would be precise. Now, precise is how close together they are, not how accurate they are. Now, independent variable is the one that you change. It is the variable that you change. So if you were to do an experiment, how does temperature affect the rate of reaction? You would be changing the temperature as you're investigating how that variable affects the rate of reaction. Then let's say we have dependent variable. Now that is the thing that we measure, is what our results and our conclusion depends on. So let's say in the rate of reaction practical, it would be the time for the reaction to occur, or the time for a specific marker of the reaction completed to appear. Now the control variable is what you control and what you keep the same. Is what you control, and you must control for your answer to be accurate, for your values to be accurate. Now, something that I did not cover in my stream so far, however it could come up, is alloys and metals. Now, in alloys, in metals are arranged like this. The positive metal ions are arranged like this with their negative delocalized electrons floating around like as such. Now, as they are arranged in layers like this, it is easy for the layers to slide over each other, which makes metals not soft, however it makes them quite soft. Like if you have sodium or lithium and you have done the practical, then as you know, you can cut straight through it and it is quite soft and malleable. So if you have a piece of copper, it is not very soft. However, with a hammer you could hit it and it would bend. However, what you have with alloys is it is two or more different metals used to make a compound like this. So you would not have regular layers. You'd have different elements, different metals used to make layers like this. Now, as it looks something like this, it's very hard for regular layers to form, and it is very hard or almost impossible for the layers to slide over each other. That's why certain alloys such as brass, you have different elements. You have different alloys. They are very strong and very suited to the purpose. You have also things like carbon fiber. However, that is topic 9 of chemistry, and that will come up on paper 2, and I'll be explaining that in that live stream. Now, as I'm still starting off with live streams, it'd be very nice if you could leave feedback in the comments and subscribe and share this channel with as many people as you can. Good luck for your exam tomorrow. I hope you do the best. Put every exam behind you. Remember that you have done your best. You have prepared as much as you can for your exams. Do not stress about your exams. Make sure you revise. Go in the exams knowing that you'll smash it. Even after the exams, if you feel as if you have not done your best, remember that you still have your next exam to come up. In your next exam, now make sure